This is my third video on my attempts to construct a small OO gauge layout. See part 1 for my reasons for doing this, and my lengthy series on my N-gauge railway modelling for more interesting stuff with trains actually running, etc. This part is devoted to wiring of the layout, and we will actually get back by the end of it to some basic demonstration running of a loco on the tracks. This is the basic Bachmann power feeder track that came with the EasyTrack starter pack that I bought. It's a bit of a nuisance, as having the wire plugging into the side of the feeder track like this makes it hard to hide the wire. Kato do a better job of this with their Unitrack, putting the sockets for their feeder tracks underneath the track with just a little nick in the side should you want to feed the wire from the side. But with the plug socket being underneath, it's easy to just drill a hole through the board under the track and feed the wire through where it won't be seen. Not so with the Bachmann EasyTrack feeder. With the power controller plugged into that feeder and the EasyTrack connected together as it came, power is supplied to all parts of the layout all the time, regardless of how the points are set. Unlike Kato Unitrack, where switching the points switches the direction of the electric power. This meant that if I wanted to have locos parked in branches or sidings whilst running other locos on the main line, I was going to have to do some fairly complicated wiring, given that I'm using simple DC, not DCC. In the centre of this picture you can see a green wire coming from the points. This is the wire for remote control of the points. These do actually come from underneath, and optionally through a nick on the side, so they can be passed through the board by drilling a hole underneath the points. The EasyTrack starter pack that I bought came with 4 sets of points, all wired for remote control. Also included were 4 extension cords for the points, so the points could be controlled from a good distance away, and 4 controlling switches for the points. All of this, of course, required wiring, in addition to wiring the power feeds for the tracks. This was my basic design at this point. The blue lines represent isolating joins, separating the track out into sections which can be individually fed with power, or not at choice. The red X's represent the points where power will be fed to the tracks. Other than the main feed at the level crossing, which feeds the main line, all of these power feeds are intended to be switchable, so that I can turn off power to those sections and so have locos parked there. To set up the intended power feeding arrangements, I needed to purchase some supplies, which I was able to get from my local hobby shop, Paris Junction Hobbies in Paris, Ontario. These Pico feed joiners should allow me to feed power to the tracks where I choose, without the need for special feeder tracks. Note that they are for code 100 rail, as I'm told that EasyTrack is code 100. I also bought this Atlas selector as a simple way of switching power to the sections. This is how the Atlas selector works. Basically, 1 or 2 power controllers can be connected at the side. Then 1 rail of each of your track sections is connected to each of the connectors at the top. The other rail of each section is permanently connected to the common rail side of the power controller. Then each track section can be connected to either controller by sliding the corresponding switch up or down, or disconnected by positioning the switch in the middle. I was actually only using 1 controller, so not making any of the connections for Power Pack B, at least at the moment. I also bought a reel of wire, and the first task I needed to do was to solder up the Pico feed joiners to suitable lengths of wire to reach to the various connection points from the controller. For this I got out my soldering station and my helping hand. That's the little sort of thing with the alligator clips to hold the wires. With the wires held in the helping hand, I soldered together lengths of connector wire to each pair of Pico connectors based on what seemed necessary given the location of the intended connection points. Once the wires were connected, I covered the joins with heat shrink. Well, obviously it's helpful to cut a suitable length of heat shrink and slide it to one side on the wire before soldering the join. Otherwise you have to slide the heat shrink on all the way from the other end of the wire, which in this case was quite long. This made fairly neat connections between the Pico feeders and the wires, which was a good thing as these needed to be fed through holes in the board. The other thing I needed to do in preparation was to set up the isolating track connections. To do this, I needed to remove the fish plates that came pre-fitted onto the easy track pieces. Then the track sections, to be isolated from each other, could be joined by replacing the metal fish plates with plastic insulating joiners, which were another thing I bought on my visit to the hobby shop, as seen here, these Code 100 plastic insulating rail joiners from Atlas. This resulted in a connection between the track pieces that would hold firm and over which trains could readily pass, but over which no electric power would be conducted. For the feeding of power using the Pico connectors, the original EasyTrack fitted fish plates also needed to be removed, then the Pico connectors were fitted instead. Because of the wires soldered to the Pico connectors, a slight gap in the tracks resulted, but I don't think this should cause any problems, certainly not where it's right by the buffer as it is here. But even in the middle of sections, I don't think it should really cause any running problems. The biggest problem in this whole process was removing the fish plates that came fitted to the EasyTrack sections. Those things do not come off easily. I first tried just getting hold of the fish plates and pulling them off, but that got me nowhere. I think there's a little hole in the fish plate which fits over a pin on the bottom of the rail, and also they may be glued in some way. Certainly they're a very devil to get off. I had to remove quite a lot of them, and I eventually got quite good at it. The trick is to completely pry the fish plate open using a small knife, with a bit of help from needle nose pliers, as seen here. The fish plates are made of fairly soft metal, so bending them isn't all that difficult. Once the fish plate is bent open like this, you can slide a knife blade underneath the fish plate and pry it loose from the track. Then, finally, you can pull it off. Unfortunately, this whole process can result in scratching up the end of the rails a bit, but hopefully not enough to really cause problems. It was unfortunate that many of the pieces from which I had to remove the fish plates were points, since obviously these are more complicated and delicate and need to be handled more carefully than regular track sections, but it couldn't be helped, as it was in the very nature of things that isolating joins needed to be placed where the points divided the tracks. Here you can see the power connections I made for the passing siding section at the left end of the layout, placed between straight and curved track sections. And finally I got the track back down. To do this, of course, I needed to make holes through the board to pass the wires for the power connections and the point controls. This was most difficult for those towards the middle of my board, where the holes had to go through the foam, then through the 3/4 inch plywood, and then through the plastic table itself. This required a long drill and was quite hard to do. It wasn't so bad for the power connections, where it was simply the case of passing two thin wires. But for the point controls, the wires that came attached to the points had to be passed, and those had plugs on the end that were something over 1/2 inch in width. I didn't have a drill bit larger than 1/2 inch and long enough to pass through all this stuff. Well, other than keyhole saws. So I ended up drilling 2 1/4 inch holes and then using a thin saw blade to saw the 2 holes together. Rather a pain, we're going right through the table, but I did get it done. The track lies flat quite well, and you can't readily see where the wires are being passed through, I don't think. This is the other end, with power connections under those buffers and a control wire under that point, and that was the most difficult one to do, actually, in the middle of the board there. For the main EasyTrack connection, I really had no choice but to make a hole for the plug beside the track. Hopefully I'll get that covered by some sort of level crossing ramp eventually. The Loco is the Bachmann Webb goods, which I bought new from British Model Trains in Cambridge, Ontario, and which has been serving as my testing engine. Here's the rather messy result in my control centre after the initial connections. Obviously I should tidy this up at some point, and the controls can be fixed down to some sort of board, although the Tech 39500 controller doesn't seem to provide any way of attaching it to a board. The Atlas selector can be seen at the bottom with all the switches in the up position at the moment, so all track connections are connected to power, and this would be the normal state to leave things in unless it was intended to have locos parked in one or more sections. Immediately above the Atlas selector is a wodge of tape covering the common connections for all the sections, the common power connections. I soldered all of those together and soldered in one wire to be connected to the power controller itself. I guess I should have used some larger heat shrink to cover this rather than masking tape, but I used masking tape because it just happened to be handy. Above that can be seen the Bachmann point control switches. One side of the left one has a red wire plugged into it, which is connected to the AC accessory connections of the power controller. Then the other point switches are all connected together, side to side, passing on the accessory power. They slide together using something like fish plates, but it's tricky to do, best done under good light, and I also use magnifying glasses to help, because they don't go together terribly easily. The green extension wires from the points themselves then plug into the tops of the point switches. I found it hard to connect the wires from the points to the extension wires. I would have thought that the connecting plugs should go all the way in, but I couldn't get them in any further than this, even with considerable force, and I didn't want to break the plugs. And though it looks ugly, they did actually work connected like this. And it wasn't just one of them, they were all like this. I couldn't get any of them to go in any further than this. Here's a close-up of the Bachmann point control switches plugged into each other side to side, with the wire from the controller AC accessory feed on the left, and the wires to the individual points plugged into the top. To operate the points, you slide the switch from side to side, then press it down. There's a fairly loud buzz from the point, and then a clunk as it changes position. The switch should then be released immediately. Here's a close-up of the Atlas selector. One side of the track connection from the power controller is connected at top left, and then one side of the track areas is connected at top. When the switches are up, power will flow to the track section. When a switch is in the middle or down, no power will flow to the track section, so a loco can stay parked there. I had to determine which way round to connect the wires to each section by trial. I put a loco on the section and then touched the wires to the track connections of the controller with the throttle set to about 40%. If the loco moved in the wrong direction, then I knew that the wires needed to be reversed. This is why all the wires from the track sections have blue marker on them. I marked the non-common side of each connection with blue marker as I determined it by testing. Here's the back of the Tech 39500 controller. The two nearest screws are for the track feed, labelled variable DC. One side of these goes to the common join for all of the track sections, and the other side goes to the selector. Well, also to the mainline connection, which doesn't go through the selector. The next two screws are labelled AC accessories, and they connect to the left side of the first Bachmann point control switch. The far two screws are labelled fixed DC and are not being used at this point. Here you can see where all of those wires from the controller go. The non-common side of the track power to the corner of the selector, the common side of the track power to the wires going to the common side of all sections connected under that wad of tape, and the AC accessory power to the point control switches. So, now let's see a little demonstration of these wiring arrangements controlling an actual loco on the layout. So here's the web goods on the layout, and we turn on the power and we turn up the throttle. Currently all of the point switches are in the default positions, so the loco goes round the main outer loop. First time it went round, it actually derailed and fell off the board at the back because I had a bad fish plate connection, which is why I've got the board on the back now. Now it's on the end section, so if I press down as I've done, see I've just turned down switch 1 on the selector, so now when I raise the throttle, the loco doesn't move on that section. Now when I put the switch back up to return power to that section, the loco does move, so switch 1 in the selector turns power to that end section on and off, the end section where you've got the two parallel sidings there. And we go around the main line. The main line is currently always powered. Now I change points 1 and 2 over. You can see the point at the front left there moving. And the train, the loco, goes round the other side of the passing siding and returns to the main line. And we'll come round again and we'll go on to that section, that passing section. Then we'll stop the loco and we turn switch 2 on the selector down, so now when I turn the throttle up, that loco won't move. When I turn switch 2 back up, the power is returned to that section, so the loco does move. Now I'm going to change point 3, so now the loco diverts into the siding. And then we'll put the selector switch 3 down, so now as I turn the throttle up and down, the loco doesn't move. Change the direction, still doesn't move. push switch 3 back up again, and then it does move. Now we'll change point 4 to move the loco onto the other siding. Stop it there, change select to 4 down, and whatever we do with the throttle, the loco doesn't move. Put select to 4 back up, and it does move. And that's basically how these controls work. The point of being able to put a loco on and not, I forgot to set the point there, that was actually supposed to go around the main line, but I forgot to change the point. The point basically is this allows you to park locos, or indeed entire trains, a loco with a bunch of wagons, in the passing siding or in the sidings, and have other locos running on the main line whilst their loco stays parked.